Hi, and welcome to this tutorial, which will look at a classic signal processing technique and how we can use it in our modern DAW mixes. Some of this video will be specific to Reaper, but the basic technique is universal and still applies in other software. I'm going to start with a demonstration. I've imported a full stereo mixdown onto track 1. I'll duplicate the clip onto track 2, then flip the polarity with the phase button. And the two tracks cancel out completely, as you would expect. This is known as a null test. When two signals cancel perfectly, we can say with certainty that they are identical. If I mute track 2, we can hear the song again. And I'll go ahead and add a re-EQ plug to track 1. With no gain applied, a clean digital EQ like this makes no audible difference. And we can verify the signal hasn't changed by unmuting track 2 again to check they still cancel. Okay, now let's dial in some EQ. I'll delete all but one band, then set a bell shape at 500 Hz and boost 12 dB with a bandwidth of 1 octave. We can clearly hear the change in the sound as a result. And of course, the null test no longer cancels. Instead, we hear the difference between the two versions, centered at the frequency I boosted. Back in re-EQ, let's tick the show phase box at the bottom right. And we now see a second plot on the EQ graph showing the phase response of this EQ setting. Note that the greatest phase shifts correspond with the steepest gradients on the magnitude plot, while the frequency I'm actually boosting is at 0 phase. Okay, I'll disable this EQ band and add another. Let's dial in the same settings, but this time cut 12 dB instead. The resulting magnitude plot is, as expected, a mirror image of the first. But interestingly, so is the phase plot. So if I turn band 1 back on again, the two bands cancel each other out, not just in magnitude, but also in phase as well. I can confirm we're back to the original signal by repeating the null test. And sure enough, both tracks cancel fully once again. If I delete band 2, and instead use a separate re-EQ instance to cancel out the first, we get the same result. The second filter has completely reversed the changes made by the first, including the phase shifts. This is perhaps a surprising result, but you might wonder what we've achieved. Well, it becomes more interesting with something in between the two filters. Actually, this principle has been in use in some form or another since the 1920s, usually to improve the performance of storage formats. Vinyl records, for example, are not good at storing bass frequencies. So before being cut to vinyl, the audio is filtered using a standard RIAA EQ curve, which dramatically boosts the treble and cuts the bass. On playback, the sound is filtered again with the opposite EQ curve, thus restoring the original frequency balance. We no longer need to worry about non-linear recording formats, of course, but we can still use emphasis and de-emphasis techniques creatively by running a non-linear process between them, by which I mean anything that changes its behavior depending on input levels. I'll load one up as an example. This is Klanghelm's free IVGI distortion plug. Let's turn up the drive so we hear it start to work. Then I'll Control-click to select both re-EQ instances, and Control-B to bypass them both at once, and notice the change in the saturation. With the EQs enabled, the 500 Hz region hits the saturation 12 dB harder, so we focus much more distortion on this frequency band. It doesn't have to be 500 Hz, of course. But matching the frequency manually for both pre- and post-EQs is a bit annoying, so I'm going to use Reaper's parameter modulation to link them. First of all, let's hit F2 to give each re-EQ instance a more meaningful name. I like to call them emphasis and de-emphasis. Then I'll waggle the frequency slider for the de-emphasis plug to select it. click the parameter button above and select parameter modulation. We have 3 options in the floating control panel, but in this case we're going to pick link from parameter and click the box underneath that currently says none. Now we see a list of all the plugs on this track, with a self reminder in brackets to indicate that the parameter we're linking belongs to the de-emphasis plug. Let's look in the sub-menu for the emphasis EQ and pick the first frequency parameter. We don't need to adjust the offset or scale sliders in this case, just leave them at their default 0 and 100% settings. And now I can adjust the frequency for my emphasis boost, and my de-emphasis cut will automatically follow, allowing me to sweep them around and quickly try out many different flavours of saturation. Let's also link the bandwidth sliders in exactly the same way. You might now be thinking, wouldn't it be cool if you could inverse link the gain controls? So increasing the boost in the emphasis EQ automatically increased the cut by the same amount in the de-emphasis EQ. Well, unfortunately there's some strange scaling going on with re-EQ's gain controls, which means this doesn't work so well. So I'm going to use a different EQ plug instead. But be aware, you do need to be a bit careful which EQ plug you choose for the job. I'm going to use another free plugin, this time Slick EQ from Variety of Sound and Tokyo Dawn Labs, and run 2 instances with linked mid-band frequency controls. Now I'll link the band gain knobs in the same way. But this time drag both the offset and scale sliders all the way over to -100%. Any boosts I dial in for the emphasis EQ are now automatically cancelled out by cuts from the de-emphasis EQ, and vice versa. In the default American mode this works fine, both instances cancel out and our null test confirms it. However, if I switch to British mode for both plugs, the null test doesn't cancel anymore. British mode is deliberately asymmetrical, so boosts are wider than cuts. This is a fairly common feature for analog EQ designs, especially those without continuous Q control, and it makes a lot of sense in that case. But if you try to cancel a British mode boost with a British mode cut, you will actually get little bumps either side of the target frequency where the boost is wider. Other things to be aware of: if I turn on saturation, either for the EQ itself or for the output section, the result will no longer null perfectly. Though in this case the saturation is pretty subtle and the null is still pretty good. However, other analog modelled EQ plugs may have stronger saturation and may not allow it to be turned off. More significantly, if I turn on auto gain for both instances, we again lose the null, with the difference becoming greater the more EQ I apply. Evidently, cuts and boosts are not given equal weight when it comes to the compensating gain applied, so our processed signal ends up louder or quieter than the original, and I find it's usually better to leave this turned off. Instead, I inverse link the gain parameters so I can tweak the gain structure manually if required. However, with saturation and auto gain turned off, and using only the symmetrical American or German modes, Slick EQ is an excellent choice. It's easy to link all 3 bands, including the shape parameters for the low and high bands, and the individual band bypass buttons. While we're at it, why not also link the main bypass parameters so we can bypass both emphasis and de-emphasis plugs in one go without having to select them both in Reaper's plugin window. Linking all parameters like this is a little time consuming, of course, so I suggest you set this up once, then save both EQ plugs as an effects chain for future use. Next time you can simply load your effects chain and drag your non-linear plug between them, and all your parameter links will be preserved. Here's my own setup using FabFilter Pro Q2. with linked low and high shelving bands, plus 3 bell-shaped mid-bands, providing more than enough control for any situation. ProQ version 1 will also work fine for this technique. But if you're using version 2, you need to make sure the proportional Q option is turned off for all the bell-shaped bands, otherwise the widths of the cuts and boosts may not match. The auto gain option in ProQ 2 has the same issue as auto gain in Slick EQ, so there will be overall gain changes with this turned on. I've linked them anyway, but I usually leave these parameters turned off and use the inverse linked overall gain controls to make manual changes to gain structure instead. The linked overall bypass parameters are more useful, as are occasionally the linked polarity buttons. Flipping the signal upside down before the distortion, then back again afterwards, is effectively the same as flipping the distortion upside down, which might make a difference with asymmetrical distortion types. As a bonus, I've also linked the overall stereo processing mode for the plug, and the stereo placement parameters for each band. When processing stereo signals, I can therefore experiment with different sounding distortion for the left and right channels, or for the mid and side channels, which can be very useful when saturating full mixes. This technique is useful whether applying heavy, obvious distortion to individual tracks, or subtle saturation over a full mix, and can produce an infinite range of different colours and textures from even the simplest of distortion or saturation plugs. For example, here's a very simple and rather boring bass sound made from 2 sine waves in resynth. And here's the sound with IVGI distortion added. And now with emphasis and de-emphasis either side of the distortion. But it's not only useful with distortion plugs. If I put a compressor in between the 2 EQs, I can change its sensitivity to different frequencies, just like EQing the sidechain. So this can be a useful technique with analog modelled compressors that don't provide sidechain inputs. Of course, if the plug also models the saturation in the analog design, you will be shaping that saturation as well, creating different colours and flavours. That's all for this video. Thanks for watching.